All right, let's talk about part one of radicals. Radicals come in all different types, but primarily we're going to talk about square roots. We'll get into cube roots and fourth roots a little bit later. But for right now, I just want to talk about two things. One, simplifying a radical, and two, adding and subtracting radicals. To simplify, okay, I have 3 steps that I wrote down. Number 1, break the value down to all of its factors. So whatever values you have in there, whether it be numbers or numbers and variables, you're going to break it down into all of its factors. For a square root, we're going to cross off every 2 of a kind. We'll get into this in the next video, but a cube root would be 3 of a kind, a fourth root would be 4 of a kind. We'll get into that. When you cross off 2 of a kind, it comes to the outside, and we're going to write the value once on the outside of the radical. And then finally, any values that are outside get multiplied together. So let's try this with square root of 72x cubed y squared. First thing I'm going to do is I'm going to break down this value. Oh, that wasn't very good, was it? Let's try that again. Break down the 72. What 2 numbers multiply to give me 72? I'll go with 9 times 8. And x cubed and y squared. I'm going to get to those in just a moment. But I have to finish my 9 and 8. They're not broken down completely to all of its factors. 9 breaks down into 3 times 3. 8 breaks down into 2 times 4. And I'm going to go ahead and kind of cheat and skip a step. 2 times 4, 4 breaks down into 2 times 2. So here's my 9 and here's my 8. Now, let's deal with the x's and the y's. I'm going to need a little bit more radical sign. X cubed means x times x times x. Y squared means y times y. Now, I have my values broken down into all of its factors, all the values that multiply to get me 72x cubed y squared. Now, step 2 says, cross off every 2 of a kind and write the value once outside the radical. Well, here's 2 of a kind, here's 2 3s. So I'm going to cross those off and write it once on the outside. I'm going to leave a little space in case I have more to write, which I know I do. Oh, I have 2 of a kind. Here's a pair of 2s. Now there's an extra one, but only 2 at a time. So I cross them off and write it once on the outside. There's a pair of x's. Cross them off, write it once on the outside. There's a pair of y's. Cross them off once on the outside. Step 3 says, values outside get multiplied. Actually, that should probably say values outside and inside. We'll get to that in a moment. These values, the 3, 2, x, and y, are all going to get multiplied. So 3 times 2 is 6, times x times y is a final answer of 6xy. Now, I still have a 2 and an x left over. Be very careful not to miss anything that you still have. They are under the radical, so they stay there. And they also get multiplied 2 times x. And that is my final answer. Now, some of them aren't so complicated. For example, I could just have the square root of 48. Nice and simple. 48 is 6 times 8. That's one way to look at it. Now, you could have said 24 times 2. You could have said 16 times 3, and you'd be correct. You should still get the same answer no matter which one you choose, as long as you're doing it properly. 6 breaks into 3 times 2. 8 breaks into 2 times 4. And oh, by the way, 4 is 2 times 2. Well, I better fix this because I'm going to need a little room. That's not going to be enough. Oh well. I have a pair of 2s, and they're going to go to the outside. I have another pair of 2's, and they're going to go to the outside. And those are going to get multiplied. And underneath, I still have this 3. 2 times 2 is 4, times the square root of 3 is my final answer. I guess that might have been a little bit better to start with than a complicated one like this. But I wanted to make sure I gave you every kind of option that you might run across. Now, in addition to simplifying radicals, we also need to know how to add and subtract them. So, when we are adding and subtracting radicals, you need to keep in mind the rule that applies to variables applies exactly the same to radicals. We are looking for like terms. You can only add or subtract like terms. Or in other words, radicals with the same value. And when you add them, you will only add or subtract the coefficients. So, for example, 3 square roots of 7 plus 5 square roots of 7. They have like terms because their radicals have the same value underneath. Both of them have a 7, nothing else. So I can add them. To add them, I'm only going to add or subtract the coefficients. So the 3 and the 5 get added together. The 7 does not change. So 3 square roots of 7 plus 5 square roots of 7 gives me 8 square roots of 7. Just like variables, 3x plus 5x equals 8x. 8 square roots of 2 minus 6 square roots of 2 is 2 square roots of 2. The square root of 2 did not change, and I just took the 8 minus 6 to give me the new coefficient of 2. But sometimes you will have some values that maybe don't match. For example, 4 square roots of 6 minus 5 square roots of 2, they have nothing in common. I cannot add these terms. Let me word that a different way. I cannot combine these terms because they do not have like values. Their square roots or radicals have different values underneath. But I can add the 4 square root of 6 with the 5 square root of 6. So that's one way I could simplify my answer. So let me go ahead and take out the blue one. 4 square roots of 6 plus 5 square roots of 6 is 9 square roots of 6. And then I have this minus 5 square root of 2 that does not get to combine with anything, so it just doesn't get forgotten. It just gets added on to the end. There's nothing else I can do to simplify this. Sometimes, however, when you have values that are not the same, and so you think that you cannot add them, please take a minute and double check. For example, 3 square roots of 12 plus 2 square roots of 48. Oh goodness. Those are nothing alike. I cannot add them as they are because the numbers under the radicals are not the same. But if we go back to the previous board and discussion, I can break down the 3 square roots of 12. So I should do that because you should never ever leave a radical unsimplified. Kind of like leaving 6 over 8. You should never leave 6 over 8. You should reduce it. You should never leave a square root of 12 because I can break that down. Let's try that. 12 is 4 times 3. And 4 is 2 times 2 times 3. Well, 4 is 2 times 2, and then this 3 gets carried down. I have 2 of a kind. So I'm going to, I'll use mauve this time. I'm going to cross them off and write it once on the outside. It will get multiplied with a 3, and I have a final simplification of 6 square roots of 3. But we have to try the 2 square roots of 48 also. All right, 48. We just did that one, didn't we? That's 8 times 6. And 8 is 2 times 4, and 4 is 2 times 2, and 6 is 3 times 2. And so here we go again. I have a pair of 2's, so I'm going to write it once on the outside. Uh-oh. I'm going to have another pair of 2's. They don't have to be right next to each other. There's one and there's one. So I'm going to write another 2 on the outside. I have a little mess going here, but hopefully I can figure out my own handwriting. 2 times 2 is 4, times 2 is 8. And what's left under the radical? There it is, it's a 3. All right, do you see it? I can add these now. They have like terms. There it is. 6 square roots of 3 plus 8 square roots of 3 is a nice and simple 14 square roots of 3. So, when you're simplifying, you want to break the values down. Every time for a square root, you find 2 of a kind, cross them off and write it once on the outside. If you're adding or subtracting 2 separate terms, make sure that they are like terms, that they have the exact same value under the radical, and then you just add the coefficients. Add or subtract the coefficients. The 3 and the 5 get added. The square root of 7 doesn't, it just gets rewritten. Okay, we don't change it. But first, if the numbers are not the same, before you decide that you cannot combine them, check and see if they could be simplified first. All right? Okay, we'll do multiplying and dividing in the next video. Thanks.